Good hydraulic design starts with layout. Many operational problems originate during the early stages of design, before pipe sizes are calculated or materials selected. The layout of the distribution network determines how water moves through the building, how easily the system can be commissioned and maintained, and ultimately how reliably it performs throughout its design life. One of the principal objectives is to minimize water age. Water that remains within pipework for prolonged periods gradually loses disinfectant residual, changes temperature, and provides increasingly favorable conditions for biofilm formation. Good layouts therefore minimize unnecessary deadlegs, avoid redundant pipework, and encourage regular water movement throughout the distribution system. Healthcare guidance illustrates this principle particularly well. HDMO 401 recommends limiting the length of pipework between a circulating main and a terminal outlet to around 3 meters wherever practicable, thereby reducing the volume of stagnant water between periods of use. Although this recommendation is specific to healthcare buildings, the engineering principle is equally relevant elsewhere. The smaller the volume of unused water within a distribution system, the easier it becomes to maintain water quality and temperature. Simple layouts also make systems easier to commission and maintain. Pipework should facilitate flushing, venting and balancing, while avoiding unnecessary complexity. In practice, the simple hydraulic solution is often the most reliable over the life of the building. Once the layout has been established, attention turns to pipe sizing. Although often regarded as a routine calculation, it has a major influence on hydraulic performance and water hygiene. Oversized pipework increases the volume of stored water, reducing operating velocities and increasing water age, which in turn raises the likelihood of temperature drift and biofilm development. Good hydraulic design therefore seeks to optimize pipe sizes, providing adequate flow and pressure without unnecessarily increasing system volume. The traditional loading unit or LU method remains the basis of most domestic water demand calculations, allowing the probable simultaneous demand from multiple outlets to be estimated. While it continues to provide a practical design tool, modern occupancy patterns and water-saving technologies mean it should be applied thoughtfully to avoid unnecessary oversizing. CIBSE Guide G provides a practical guidance on the application of loading units within the wider context of building water services, complementing BSEN 806 and BS 8558. Water velocities also require careful consideration. Excessively high velocities increase pressure losses, noise and the potential for erosion at fittings, while very low velocities reduce the self-cleansing effect of flowing water and encourage sediment deposition. Material selection forms part of the same process. Copper and stainless steel continue to offer excellent performance in many applications, while polymer systems have become increasingly popular because they combine corrosion resistance, low weight, and ease of installation. Modern systems include PEX or PEX, PERT, and PER, a multi-layer composite pipe or MLCP, each with characteristics suited to different applications. MLCP, for example, combines the flexibility of polymer pipework with an aluminium layer that reduces thermal expansion and acts as an oxygen barrier for closed heating systems. Unlike metallic pipework, polymer systems expand more when heated and therefore require appropriate support spacing and provision for thermal movement. As shown in Table 1, multi-layer composite pipes exhibit significantly less thermal expansion than single material polymer pipes, although movement must still be considered when detailing supports, anchors and changes in direction. Successful installations therefore depend not only on selecting an appropriate material, but also on integrating pipework, fittings, valves, pumps and terminal equipment into a well-designed hydraulic system.